Hi friends. So after completing the numerical on Laplace transform of integral, let's move ahead with one more numerical on Laplace transform of integral. So here I'll be taking a different function and let's see how to apply that property to evaluate the numerical. So here we have to find out the Laplace of integration 0 to t u e to the power minus 3u cos square to u du. So guys, here this question, or I would say this integration that is from 0 to t, reminds me about Laplace transform of integral property, because in the Laplace transform of integral property we have integration from 0 to t. So what is the property? So here I'll show you. So as per the property, the Laplace of integration 0 to t f of u du is given by 1 upon s phi of s, and to get phi of s we have to find out Laplace of f of t, and guys, f of t is nothing but r f of u. So in our case, if I compare this term with the question, then f of u is u e raised to minus 3u cos square to u, and for that I will find out the phi of s. So here I'll say so this f of u, I'm gonna treat it as f of t. So this will become t e to the power minus 3t cos square of 2t. Now guys, let's find out Laplace of this, because that is gonna be phi of s. Now how to get Laplace of this? Because here there are three functions which are multiplying each other, so we cannot find out Laplace of each term separately. So to get the Laplace of this, we have to either convert it in such a form that we can apply the standard formula of Laplace transform, or we can apply some property of Laplace transform. Now for that, what I'll do is, the cos square 2t term, I will replace it by the formula of trigonometry. So this will become t into e to the power minus 3t, and the value of cos square of 2t is 1 plus cos of 4t whole upon 2. Now guys, after this 1 by 2 is a constant, I'll take it outside. So 1 upon 2 outside, and I'll multiply this numerator with t e to the power minus 3t. So this will become t into e to the power minus 3t plus t into e to the power minus 3t into cos of 4t. So I've simplified this given function, and now to find out Laplace of f of t, we can find out Laplace of these two different functions. So to find out Laplace of this first function, guys, I'm going to use a property which is called as first shifting theorem. So let me show you what is the first shifting theorem. So in first shifting theorem, we have seen that your function must be in the form of e raised to at into f of t. So you can see here that it is in the form of e raised to at into f of t. So f of t is t. Similarly, in the second function, there are two properties. So this is in the form of first shifting theorem as well as multiplication by t property. So second time I'm going to use two properties. So let's start. So what I'll do is, I'll consider this as equation number 1 for time being, and then I will solve each term separately, and then we'll put these values in equation number 1. So here I'll say, therefore Laplace of f of t is equal to half Laplace of e to the power minus 3t into t plus Laplace of e to the power minus 3t into t cos 4t. Now let's solve first term. So Laplace of e to the power minus 3t into t. So I'll call this as equation number 1. Now guys, here by the first shifting property, value of this is phi of s plus 3, because here this power is negative 3, so that will become positive 3 in the answer. Now to get the value of phi of s plus 3, we want phi of s, and phi of s is nothing but Laplace of f of t. Here f of t is t. So here I'll write where phi of s is equal to Laplace of t, which is nothing but 1 upon s square. Now guys, in this value of phi of s, I'm gonna put s as s plus 3 to get phi of s plus 3. So this will become 1 upon s plus 3 the whole square. So here I got Laplace of this first term. I'll call this as equation number 2. Now let's find out Laplace of the second term. So here I'll say Laplace of e to the power minus 3t into t into cos of 4t. Now guys, let's see how I'm solving this problem. So if you see here, and if you treat this as e raised to at, then this becomes your f of t. So here I can apply the first shifting property. Now I'll say here that here f of t is t into cos of 4t, and whatever is the Laplace of this, I'll call it as phi of s. So guys, if we'll see the first shifting property, then it says that e raised to at into f of t is phi of s minus a. Now in our case, if this is f of t and this is e raised to at, then value of a is negative 3. So that will become s plus 3. So here I'll call this as, it is equal to phi of s plus 3. And now I will find out the value of phi of s, and in that I'll put s as s plus 3. So this will become Laplace of f of t equal to Laplace of t into cos of 4t. Now guys, to find out the Laplace of this function, here it is matching with multiplication by t property, because t into some function. So I will be applying multiplication by t property, which says it is equal to minus 1 raised to 1 d by ds of function of s, which is the Laplace of this function. So it is s upon s square plus 4 square, or I can say it is as 16. So this will give us minus sign as it is. Inside I'll be applying u upon v rule. So that will become s square plus 16, that is v. Derivative of u, that is derivative of s, is 1, minus u, that is s, and the derivative of v, that is derivative of s square plus 16, it is guys 2s, whole upon s square plus 16 the whole square, because in denominator we write v square. So let's simplify this. By doing that, we will get s square plus 16 into 1, that is s square plus 16, and this is minus 2s square upon s square plus 16 the whole square. So this will give us minus s square plus 16, and due to the negative sign, that minus s square will become positive s square, and that positive 16 will become negative 16 upon s square plus 16 the whole square. And guys, this is nothing but phi of s. So we are going to use this phi of s here to find out phi of s plus 3. So that is why the Laplace of e to the power minus 3t into t cos of 4t is nothing but phi of s plus 3. So replace s with s plus 3. So this will become s plus 3 the whole square minus 16 upon s plus 3 the whole square plus 16 the bracket square. So this is nothing but s square plus 6s plus 9 minus 16, so minus 7 upon here s square plus 6s plus 9 plus 16, that is plus 25 the whole square. So now we got the value of Laplace transform of e to the power minus 3t into t into cos 4t. Now guys, we will call this as equation number 3, and we are going to use this equation number 3 and equation number 2 in equation number 1. So here in equation number 1 we have to substitute two values. So we got first value in equation number 2 and second value in equation number 3. So now I will substitute equation number 2 and 3 in equation number 1. So here we'll say substituting equation number 2 and 3 in equation number 1. And guys, equation number 1 is our question. So here Laplace of f of t is equal to 1 upon 2 in the bracket. Now this value is 1 upon s plus 3 the whole square. So it is 1 upon s plus 3 the whole square as it is, plus now the second value that we got in equation number 3. So this is the value. I'll put this value over there, and that will become s square plus 6s minus 7 upon so guys, here I got Laplace of f of t, and f of t was this function, that is f of u. Now after this, let's apply the property which is Laplace transform of integral, because we also have this integration sign, and by applying Laplace transform of integral we will get our final answer. So I will call this as phi of s, and now we will say using Laplace transform of integral property, it is equal to 1 upon s phi of s. So 1 upon s and phi of s. So phi of s is this value. So here I'll write down 2. So that will become 1 upon 2s, and in the bracket 1 upon s plus 3 the whole square plus s square plus 6s minus 7 upon s square plus 6s plus 25 the whole square. So guys, this is the value of given function of t. So I'm sure that you understood how I've applied Laplace transform of integral property along with the first shifting property and multiplication by t theorem. So guys, if you like this video, then don't forget to share it with your friends. And if you want to learn more videos on engineering mathematics, then don't forget to visit ekida.com, because that is the only place where you will get all my videos. Thank you very much.